Hello everyone. My name is Gleb. I'm a data engineer at Globallogic, and today I want to talk about one adventure of migration machine learning engine. So machine learning engine, it's a bit clickbait name. Basically, it's several Python programs that used to boost customer performance by providing recommendations to improve some processes regarding planning, product utilization, and allocation. And migrations happens almost with every digital product once a lifetime. So, and this is at some point of time, this product also start this process. But even having machine learning algorithms in the core, this migration is basically migration of data flows as the main processes of any part of programs that utilize machine learning. And today I want to touch such topic related such topics which caused most of problems with this migration, and all of them were related to the data processing stuff, starting with data infrastructure limitations we met at the target, then overview data management at the project and how it affects the whole process. Also, I want to speak a bit about lack of, that was specific for this engine, lack of separation, data engineering part and machine learning. So let's start with overview of a data flow from this project. The storage of customer data was Amazon S3. Files and data were ingested to the storage from external sources by ETL process, and this is what owned by customer company. And machine learning engine run on the third-party vendor infrastructure. They created a SQL interface on top of most of the data on customer in Redshift Spectrum in particular, but some file they read it directly without the SQL interface. Each module deployed as a Docker image somewhere on their infra. All data processing, data reads, and calculation performed at the single runtime, and final output provided also on S3, ready for consuming by end users, which are analysts from merchandise department, basically. Start migration started with like target infrastructure requirements, and among of them was performing machine learning algorithms in customer SageMaker service. They wanted to migrate only the code and abandon abandon the rest of infrastructure. For the data engineering purposes, we were supposed to use Kubernetes cluster with services running Spark, Hive, and Airflow there, and this cluster already in use to ingest data to S3 bucket during ETL process. Right after the start, we found out that we cannot use direct connection from SageMaker to this cluster due to incompatible environment, basically, for machine learning and one we have on Spark, because these services were really outdated. And resolution of this all dependencies was quite difficult, and it was decided to change the interface for data. And the process of migration divided in such parts. First is to migrate this SQL interface to Hive Metastore, because they actually have a very rich database there, a lot of dependencies on it, and we cannot just skip and refactor to some another process. Then the next part is to split all entities in a regional solution to data engineering and machine learning part, as we call this. In data engineering parts, we utilize SQL interface, and all like high-level transformations for machine learning, we keep the rest of things that utilize machine learning algorithms. The next step is set up interface between these parts, available and reliable for these purposes, and as a final step, orchestrate module, run and control the quality, like compare a migrated solution with the source one. let's keep a bit closer to this SQL interface. Well, the base solution looks like this. Files on top of the files on S3 created base table definitions. Then there is another layer of tables based on different business queries, also implemented in materialized way with unload process. Then another layer of SQL query that used to get data into engine. Not so many updates we made to this structure, but we wanted to avoid this additional unload process. As soon as it might be in the original solution, it might be not very reliable, and we do not wanted to outages in the data access. We wanted to have all data available just right after ETL stops. So instead of this unload, we added additional step to original ETL process that already existed in cluster to repartition data for better querying. We save same table definitions about the data, and instead of tables, we utilized view structure, and the query stays the same, almost the same, except that whole SQL should be translated to the Hive dialect, which is not very difficult, but routine work. Few words about this SQL interface. It's actually very powerful technology, widely used and highly standardized. It allows having like whole stuff in one place in MetaStore, and there are strategies to optimize the queries, but when you set up such interface for data, you should keep in mind that originally it required a proper data model, and you should make an effort to create proper data model to use it, to avoid this like hierarchy of different queries and cross dependencies between all of them. And also like version control of data sets that SQL based may be quite difficult. This when you may have in your database like table v1, table v2 problem, because several instances of table should exist at one moment, and that's not always a good practice. You should consider these disadvantages of SQL as well. The next part is to divide data engineering and machine learning parts, and for this project it was absolutely necessary because we cannot use SQL interface in SageMaker, but in general it's good practice to separate stuff, keep them in separate modules or repositories that allow to perform work in parallel, because a focus of data engineering and machine learning it's quite different. Data engineering focused on providing highly available and proper data for machine learning parts, and the code base should be focused on the algorithm related stuff. This is a question of organization, but it helps them to understand product better. So how split were performed? It was very simple. By the structure, we take the entity from original solution, like whole script or maybe some function, define the parts where we need SQL, and based on these parts we create a Spark job. The rest part that utilized machine learning algorithms, we created a SageMaker job for this. Refactor required parts for this, and data engineer and machine learning engineer work in collaboration to agree about how these parts should be connected between each other, and we set up a file interface between this. So new data flow looked a bit different. Now whole available data with SQL or without utilized by Spark job performed transformations, and it provides output that ready for direct import to the machine learning model. This output created based on so-called data contract. Data contract is actually a document of agreement about how data should look like when we have two parts of product that communicate using this data. Additional moment here is a metadata file, which also updated when new data portion is unloaded, and this metadata file is used by machine learning job to define which data should be read. In the casual process, it should read like the latest unloaded data, but for some purposes, you can configure to read another portion. And compare the processes. Unlike the single environment and run on the original solution with multiple reads and all calculations in the memory and providing final output, we have basically a pipeline with staged data between before each model run. We lose the time when we need to set up each instance, but we have some benefits from reliability, because we don't need to run the whole process from the very beginning in case of fail of some steps. We can start right from the last failed step as soon as previous one finished successfully. Also, for this setup, you can create absolutely separate data quality framework without changing the code base. As in our case, code base is very messy and hard to refactor. So having things separate is very helpful. Yeah, and when we created this new process, we need to confirm that model actually works, and the only thing that we have available is the only final output. Each model can utilize 3 or even more models, but almost nothing data that used intermediate inside this process is not available easily. So if a final output is not the same, even with reading the same data on S3, we have to find some ways how to print out or some stage update process, original process, to have this intermediate results to check this parts of the program. But this problem can be avoided if you have a more module approach when you deploy your pipeline. And this actually was a major 80% of the time spent of debugging of this process. A bit details about how pipeline setup in SageMaker. We create for each model in each module. We create a SageMaker pipeline with only one step with this part. We try to make these pipelines configure as much as possible, and utilize job arguments that passed from the process that schedule these pipelines. The whole module, after this refactoring performed, the whole module orchestrated in Airflow. As I said, we had this Kubernetes cluster, and the base operator Fireflow was chosen as Kubernetes spot operator that we configure to do basically two things. The first is a configure to run as part job for data engineering part, and another is configure to start this SageMaker pipeline. Define the structure and deploy during CI/CD process. We utilize this feature of dynamic doc generation for the repeatable processes when we have same pipeline structure for example, several product categories the customer has. Setup of pipeline looks very simple. Here is simplified pipeline from 2 steps in Airflow. Inside at each iteration we create a pipeline with required amount of steps and required steps data engineering or machine learning, and create this loop to dynamically generate several pipelines. In general, modules then looks something like this. Usually steps there are much more steps in this. And now on this module, instead of this image deployed somewhere, having pipeline and utilizing user interface of Airflow, it's easily to find out if process set up correctly, if we have correct order of steps in pipelines, if we use parallelization every way we can, and in case of failure, it's obviously and observable which part has failed. Airflow allows to define this recover or retry policy specify like notification in case of failure of some steps, and also provide resources for Kubernetes pod from Airflow is also possible independently from the pod from the image that we deploy to this pod. This also added flexibility to our solution. So, and well, here is a list of like benefits, I would say, of this pipeline approach instead of like automation of some scripts which try to utilize like all things within one environment. And the main goal of this project was migrate solution and run on the new infrastructure, and it was achieved. We utilize parallel running, and now we have more clear monitoring. I cannot say for now that we improve performance of pipelines itself, but I believe that with this structure, it's more ready for like further improvements. So, yeah, as a conclusion, I want to emphasize that for machine learning projects, like data engineering part is also very important because on the quality of data depends like how good the final model output will look like. And the key of success of this project was a collaboration between engineers from different disciplines, like data engineers, machine learning engineers, and data scientists who implemented the original solution. Only after like set up a connection between us, we find out the way how to build this. Yes, I think, okay, I think I'm done, a bit earlier than expected. Yeah.
Okay, do you have any question? Do you have any questions? Want to ask? Came to you with a microphone. Okay, maybe I ask the question. How big was the team you work for?
The team basically consists of 2 data engineers and 2 machine learning engineers. It's our Globallogic part of team who perform migration. Also, there are several data scientists on the third-party vendor which solution we migrate, but they participate only like on consulting about some questions regarding original solution.
Okay.
Yeah.
How long did it take you to migrate?
Yeah, we start migration like seriously on May and finished on October. But as far as I know, this process took more. There are like not the first iteration for this project. The previous one was abandoned, I believe, because no one wanted to deal with this mess of code. Like, this was like spaghetti code, indefinite, and each problem you should like when you have wrong attribute in the final file, you have the whole journey from the pandas transformation to the one SQL layer to the another, and while we found the issue.
So the initial attempt was using different technologies, different stack?
Probably yes, but I'm not aware.
Okay. Any more questions? Okay. Thank you, Gleb.
Thank you.